So just recapping where we are in the project at this point, we've ingested our imagery, we've performed nominal georeferencing, and we've gotten to the point where we have done a coarse alignment. So we're at the stage now where we need to assess the quality of our coarse alignment and identify problem areas. So let's do that using Ortho Engine. What we can do is we can load up the project that contains the coarse alignment. So let me just open up a window here and browse to the folder where I have the data for the coarse alignment. Okay, so this is the stage 1 project, so I'll load that up in Ortho Engine, and I'll just double check. Looks like everything's okay, 40 centimeters, the right projection, and so on. And what I could do is I can pull up the GCP tie point collection panel and open up the project overview. So a nice thing that I can do is I can open up the overview window. So let me just zoom to the extent of the images here, and then I'll also open the panel. And what this is telling me is where maybe some problem areas are residing. So let me just recompute the model. It needs to recompute the model to give me the information. So if I look at my RMS values, what this is telling me is for each image, how many ground control points and tie points I have, and what's the GCP residual error and the tie point residual error on a per image basis. And I can see right away that I've got a problem in this particular image. So if I sort by GCP RMS, this one is obviously quite a bit off from all the others. So let me just double click on this one, and what it's going to do is it's going to open up the image. And let me zoom out here. And I'll turn off the tie points because those are fine. And what I'll do is I'll turn on the residual display for the ground control points. So there you have it. So these ground control points look like they're okay, but these ones are obviously pretty bad. So I can use my select tool. This one looks to be the worst one. And it selects it in the table. And I could just delete it directly from the view. Recompute my model. And you can see that my RMS is already improving. It's gone down from, I think it was at 27 and 26 down to 17 and 25. So let me select another bad ground control point here. And while I'm at it, I'll delete this one. And I will also delete this one over here. And I'll recompute my model here. You can see that my RMS is now below 11 meters, which is quite good. So that's a nice visual way to assess the overall accuracy of the project. So I could continue with that strategy. I could sort by RMS, maybe load up the next one that's got quite some problems here, and turn off the tie points and show the residual ground control point errors. Maybe I can get rid of this one here. And what this allows me to do is to make sure that I've got good spatial distribution of my GCPs across the data set. So I'll delete this other one here, close that down, close this down, and I'll recompute the model. So it looks like I'm down again just a little bit below 11. The other strategy I can take is I can sort by residual error. So you can see that I've got some points here that are quite high in terms of the residual error. This one's a bit of an outlier. It's at 95. So maybe I could delete these top 3. Let's see what that does. Recompute my model. So I'm pretty good now. I'm down below 10 meters. So I'm pretty happy with that. I've got, if I turn on my display and I show the ground control point distribution, looks like I have ground control points on all of my images. There's no islands where I don't have any ground control points. I can also show the tie points, and I can just turn off the ground control points to make sure that I can see those clearly. So the tie points look really good. I have many multi-way tie points, so these are tie points that are basically showing more than one connection. These are 7 or more tie points, 6 or more, 5 or more, 4, 3. So you can see that I have quite a few with 3, and then several that have 2. So this just gives me more confidence that my model is going to be quite good, well distributed, and high level of accuracy. So I'm going to close this down now and save this. And my next step is going to be to move to the fine align stage.